Hello students, today we will be going over 11.4a recursive formula for arithmetic sequences. And your objective is I can use and write recursive formulas for arithmetic sequences. And for recursive formulas, they have two parts. Part 1 is to state the starting term A1. Part 2 is the formula relating the successive terms to the previous term, a to the n minus 1. So you have this arithmetic sequence right here, and for honor students, you are on page 157, and for non-honor students, let me see, you are going to be on page 145, okay? So 145 for non-honors or regular students, and 157 for honors, okay? So you have this arithmetic sequence. Now, they put it in the table and they did not write it correctly, so I want you to make these changes. Right here, I'm going to put AB, which means term 1 should not be 5, it should be 10. Term 2 is not 10, actually it should be 15. Term 3 should not be 15, it should be 20. Term 4 is not 20, it should be 25. And term 5 is not 25, it should be 30. Okay, so make sure you're writing those changes. I'm trying to make sure I can know how to do this. You want to block this out. Anyway, block out the 5, the 10, the 15, the 20, and the 25. So I thought that would block it out with that, and it did not. So it's a learning experience for me. Okay, it still doesn't seem to want to work there. All right, so make those changes. And the other change we need to make is that on this, and we'll fill out the last one later. We're going to go over how to figure out the recursive formula there. Now, the graph is also incorrect, so we want to go by this set of numbers, which means this is the correct numbers on the side. These are not correct, so we're going to go ahead and put those in. And 1, your first term is what? See how the first term is here and the first term is there, so it should be at 10. Okay? Second term is at 15, so we're going to do that as well. Whoops. I'm going to undo that one. And then the next one should be right here. And the next one, and next one is here, and I should probably make them a little bit smaller or a different color, but for emphasis I'm having you see where you need to make those changes. Okay, all right, and we'll make the last one. That way you've made those changes. This table should match up with this graph, and it should match up with these numbers here. So again, function notation, this is f of 1, f of 2, f of 3, all of those are function notation. Sequence notation is like a sub 1, a sub 2, a sub 3. They all mean the same thing with the term number, and then they all have the same term with term 1, 2, 3, 4, term 1 being 10, term 2 being 15, term 3 being 20, etc. Okay, now the process of writing a recursive formula for an arithmetic sequence. First of all, we make sure that it is an arithmetic sequence. Okay, we're going to find the common difference, and you always take the second number and subtract the first. We start with something very easy, and so you can do it mostly in your head. So 10 plus 5 is 15, 15 plus 5 is 20, 20 plus 5 is 25, etc. And if it's a really hard one, again, you take the second term minus the first, and you can find the common difference. So we know here it's going to be, you're going to be adding 5 each time. And since it's all the way through, we can put over here, yes, there is a common difference and it is arithmetic. And then you create a recursive formula by stating the first term and then stating the formula to be the previous term plus the common difference. So your first term, A1, always state the first term. Here it's going to be 10. Okay? So, and then you would say A to the n, and that's just a generic term. Say I wanted to find the 30th term or 50th term or 100th term. How would I do that? Well, if it was the 50th term here, we would find what the 49th term was and then add the difference. If we were trying to find the 100th term and n was 100, we would try to find the 99th term and then add the common difference. So hopefully you can kind of understand that, how the n and the n minus 1 works. Again, whatever term number you're trying to find, it's the previous term plus the common difference there. So we're going to practice, and here's just some notation, and I put this also online for you. So you know the first term is A1 in sequence notation. That same first term in function notation is f of 1, and that's how you say it, f of 1. This one over here, a to the n, this could be a sub 1 or a1 equals the first term. A sub n equals a to the sub n minus 1 plus d. That just means whatever term you want to find, whatever n is, it's the previous term, so it's the n minus 1 plus your common difference. Function notation, f of n equals the one previous, which is f of n minus 1, plus again the common difference. So you just need to become familiar with these two, the terminology that's used, and know and become familiar with that. Okay? A1 is the first term, f of 1 is the first term. A to the sub n is the nth term in the sequence. F of n equals the nth term in the sequence. A to the n minus 1 equals the term before the nth term. Again, f to the n minus 1 equals the term before the nth term. N is the term number for both of them, and d is the common difference, even though it's what you're adding to the previous number, not really subtracting. But to find it, you could take the second number, subtract the first. So here, we have our set of numbers again listed from the top. A1 is 10, because it's the first term. We always list the first term, okay? In both notation. Here it's A1 is 10, here f of 1 is 10. So then we say, well, what was d? Remember the d, we were adding 5 each time. So to find a to the n, or f of n, it equals the previous term, and this is how we list it in this notation, a to the sub n minus 1 plus 5, or in function notation, f of n minus 1 parentheses plus 5. So that's how that would be, that's how that would work, okay? And these statements all name the same sequence, okay? Basically, A1 equals 1. Now, we're done talking about this one, so this is a brand new sequence. But these three notations here are going to be all the same. And basically, this is just a number line. So A to the n, we don't know what that is. The example we did before was like n was 7. Remember, this was a to the 7th term, a to the 8th, a to the 9th, a to the 6th, and a to the 5th. Remember when we did that? Here, this function notation, a to the 1 is 1, a to the n equals a to the n minus 1 plus 4. This is f of 1 equals 1, f of n equals f of n minus 1 plus 4. That means you're going to start at 1, and you're going to be adding 4 each time. So in other words, this is what that would look like. The sequence would be, and I would put start at 1, and then if I add 4 each time, it would be 5. And if I add 4, 9, add 4, 13. And if I add 4, 17. And then that's what that would look like. And this is the way you write it in function notation right here, okay? So a to the n equals a to the n minus 1 plus 4. So if I wanted to find the 100th term, I could find the 99th term and add 4, and that's what you would get. Okay, this is just the introductory part, and I will give you more instruction in the coming parts. Have a great day, students. You rock.